Hello there, hope everyone is doing well and staying safe. In this video, I wanted to go over the basics of Git and try to demystify what Git is all about. Additionally, I am making the assumption that you already have Git installed. If you have not, check out the link down below in the description section to get Git installed. So let's get started. We are going to be taking a look at Git from a higher perspective, at a very basic level without getting into too many technical aspects of how Git works under the hood. First, let's start out with the two main concepts of repositories. One, we have a local repository, and the second is a remote repository. A local repository is where the version control happens on your local machine. You can make changes, track history, and perform various Git operations all locally before syncing your changes with a remote repository when you are ready to share your work with others. This means that the local repository is stored on your computer's file system. It contains all the files and directories of the project along with the complete history of the changes. Every commit made to the project is stored in the local repository, creating a complete history of the project's development. Unlike remote repositories, you can work with your local repository even when you're not connected to the internet. This allows you to make changes, commit them, and perform various Git operations locally before pushing changes to a remote repository. You can also create branches, make commits, merge branches, and perform other Git operations without needing an internet connection. You can initialize a local repository in an existing project using the git init command. This creates a hidden subfolder within your project that houses the internal data structure required for version control. Well, the remote repository is the opposite of local repository. It's there as a centralized location for storing and sharing your project's code. It facilitates collaboration, provides backup, and serves as a hub for managing the development of your project. What I mean by this is, remote repositories are often hosted on servers and popular platforms for hosting Git repositories, including GitHub, GitLab, Bitbucket, and others. These services offer additional features such as issue tracking, code review tools, and collaboration features. Remote repositories enable collaboration among multiple developers. Team members can clone the repository, make changes, and push those changes back to the remote repository. By hosting your code on a remote server, you create a backup of your project. In case of data lost on your local machine, you can recover the project by cloning it from the remote repository. The remote repository serves as a centralized code base that team members can reference and contribute to. This ensures that everyone is working with the same set of code and history. Depending on the permissions set by the repository owner, team members can have read-only or read-write access to the remote repository. Now that we have covered the two main repositories for Git, let's take a look at our first instance. Initially, there are two ways to start out with Git once it's installed in your machine. Initializing an existing project that has no Git source control existing in the project, or cloning a project down to your local Git machine through Git. To start out with initializing an existing project, you will need to be utilizing a Git command called git init. Git init is designed to, at a basic level, create an empty Git repository to reinitialize an existing one in a local setting. Since it creates a local Git repository, initially the local repository will not have any connection to the remote source control until it is manually pushed to create the remote control counterpart of it. For example, a user is in a specific directory they wanted to create as a Git repository to track their work locally and experiment with local branches for a variety of future implementations. They execute the git command git init to create a local repository. This creates a local repository that it isn't connected to anything. However, it doesn't mean that it's not tracking any changes or you aren't able to do anything with it. Everything is tracked in the local repository. Once you decide to push your local repository to remote source control, everything that has happened within the local Git repository will be pushed to the remote, creating that specific remote repository. Note that git init is also a safe command where running git init on an already existing repository will not override things, but rather it will pick up new templates. You can also move an existing Git repo to a different directory with it, but we aren't going to be covering that in this video. The next way to start out with Git is to clone an already existing repository that is located in remote source control, such as Azure DevOps or GitHub. In order to do this, we will be using a git command called git clone. Git clone will clone the repository with the given remote repository URL into a newly created directory inside the designated location of the directory you are in or have selected. By default, git clone will clone the desired repository into the current local file system location and bring all of the mains, or rather remote/origins history and files with it. So by cloning, you are cloning the default branch, in most cases the main branch, down to your selected directory and creating a local git repository that is now manually linked to the source control. Now that we have covered how to initialize or clone a git repository, I'm going to cover the git command required for basic git workflow. These are git add, git commit, git push, git fetch, and git pull. First, let's start with git add. The git add command is used in Git to add changes from your working directory to the staging area. The staging area is a crucial step in Git's workflow, allowing you to selectively choose which changes you want to include in your next commit or all of the changes if needed. Here's a brief explanation of how git add works. Before a file is committed, you need to tell Git which changes you want to include in the next commit. This is where the staging area comes into play. The staging area is like a checkpoint where you can review and organize your changes before making them part of the permanent record. To add changes to the staging area, you use the git add command followed by the names of the files you want to include in the next commit. You can add specific files with git add file 1 or file 2, or you can add all the changes in a working directory by utilizing git add period or git add -a, or you can add all changes to a specific directory by utilizing git add directory /. Once you are ready to commit your changes from the staging area, that's where the next command for the basic Git workflow appears, the git commit. The git commit command in Git is used to save the changes that you have staged in the staging area. It creates a new commit in the version history of your Git repository. Each commit represents a snapshot of the project at a specific point in time, and it includes the changes you made along the way with a commit message that describes the purpose of the changes. When you run git commit, Git opens a text editor, usually configured as the default editor on your system, where you can enter a commit message. The commit message should be a clear and concise description of the changes that were made in the commit. Or you can use git commit with a -m flag to just commit with a message altogether. After successfully committing, Git generates a unique identifier called the commit hash. This hash is a long string of characters that uniquely identifies the commit and can be used to reference it in various Git operations. You can use git log to view the commit history of the repository. This shows a list of all commits, their hash, author information, date, and commit messages. In summary, git commit is the command used to save staged changes to the Git repository. It captures a snapshot of your project at a specific point in time and allows you to track the history of changes over the course of your development process. Once you have everything committed, you are then ready to use the next git command we'll be going over, the git push command. The git push command in Git is used to upload the local changes, commits, to a remote repository. This is typically done to share your work with others or to update a central repository with the changes you have made locally. I'm going to assume you already have your remote repository set up and have permission to push. Before using git push, you need to commit your changes locally using the git commit command, as mentioned previously. Git push is used to update a remote repository with the committed changes from your local repository. The remote repository is often located on a server such as GitHub, GitLab, or Azure DevOps, as mentioned previously. The basic syntax of the git push command is as follows: git push, remote name, and branch name. If the branch name on the remote repository is different from the local branch name, you can specify the remote branch name during the push. When you run git push, Git uploads the new commits from your local branch to the specified branch on the remote repository. Depending on the configuration and the remote repository settings, you may be prompted to enter your credentials, username and password, or access token during the push. If you set up branch tracking using git branch -u flag or git push -u, You can use git push without specifying the remote branch and the branch names in subsequent pushes. In summary, git push is used to update a remote repository with your local commits. It's an essential command in Git for collaborating with others and keeping remote repositories in sync with your local development. Next two commands are also crucial for basic Git workflow, and it is actually super duper highly recommended that you utilize the next set of Git commands, git fetch and git pull, in your basic Git workflow. Without going too much into it, let's start out with git fetch. The git fetch command in Git is used to retrieve changes from a remote repository, but does not automatically merge those changes into your current working branch. Instead, it updates your local references to the remote repository, allowing you to see what changes exist without incorporating them into your local working directory. When you run a git fetch, Git contacts the remote repository specified, usually named origin by default, and fetches any new commits, branches, or tags that exist in the remote repository but not in your local repository. Git updates your local copy of remote tracking branches to reflect the changes made in the remote repository. Unlike git pull, which we'll talk about in a bit, which automatically fetches and merges changes into your working branch, git fetch leaves your working directory unchanged. It fetches the changes and updates remote tracking branches, but doesn't modify your local working files. After fetching, you can use commands like git log or git diff to inspect the changes that were fetched. You can also check the status using git status. Once you fetch the changes, you can decide to merge them into your local branch using git merge, or rebase your changes on top of the fetched changes using git rebase. But we won't be going over that in this video because I think it's a little bit more advanced. The basic syntax of the git fetch command is as follows: git fetch and the remote name. You can also fetch changes for a specific branch from the remote repository with git fetch, remote name, and branch name. In summary, git fetch is a command that fetches changes from a remote repository, updating your local references to reflect the state of the remote repository. It's useful for inspecting changes before deciding to merge them into your working branch. Now that we have covered git fetch, let's take a look at our final Git command, git pull. The git pull command in Git is a combination of two operations, git fetch and git merge. It is used to retrieve changes from a remote repository and automatically merge them into your current working branch. In other words, git pull fetches the changes from the remote repository and incorporates them into your local working branch. Like git fetch, git pull contacts the remote repository specified, usually named origin by default, and fetches any new commits, branches, or tags that exist in the remote repository but not in your local repository. After fetching the changes, git pull automatically merges them into your local branch. It performs a git merge operation to combine the changes from the remote branch into your working directory. Git pull also updates your local copy of remote tracking branches to reflect the changes made in the remote repository. If there are any conflicting changes between your local branch and the remote branch, it will attempt to perform an automatic merge. If the automatic merge is not possible due to conflicts, you'll need to resolve the conflicts manually. I won't be covering merge conflict resolutions in this video, as I think resolving merge conflicts are above what a Git basic workflow might cover, but I wanted to mention it as it's part of the Git workflow, but not at a basic level. The basic syntax of the git pull command is as follows: git pull, remote name, and branch name. And if you are working on a branch that tracks a remote branch, you can just simply use git pull. In summary, git pull is a convenient command for updating your local branch with changes from a remote repository. It combines the fetch and merge operations into a single command, making it a quick way to synchronize your local branch with the latest changes from the remote repository. Well, those are the basics of Git that cover a basic Git workflow. Even if you are using an IDE like Visual Studio, these are the basics of commands that are used in a Git workflow. A basic Git workflow might look like this: git fetch, git pull to make sure your local repository and branch is up to date, do some work, git add, git commit, and git push. One final note I would like to make is I didn't go over git stash on purpose, as I think it's above a basic git understanding or basic git workflow, as it's not actually needed in git commit process. However, such case is that it is a handy command for temporarily saving changes that are not ready for committing, and helps you switch branches, apply fixes, or perform other tasks without committing incomplete work, and later you can reapply those changes when you are ready to continue working on them. But again, this isn't part of a git basic workflow, but rather it can be part of a regular workflow. I personally don't use it unless I need to apply patches to a previous commit if needed. We'll cover this more in another video in the future. Thank you for watching. If you have any questions on database concepts, DevOps, or anything computer science related, feel free to post them down below. If you like this video and would like to see more, please don't forget to subscribe. See you next time.